Alright, so this week we're going to start talking about bonds. Bonds are, we can look at them as being strong or weak, depending on the energy involved in them. If we have a bond that minimizes energy, then it is going to be a strong bond. If we have a bond that maximizes energy, that will be a weak bond. So just like everything in chemistry, it's backwards, right? The first bond that we're going to look at is the ionic bond. And that one, if you'll remember, is when I have something like sodium and chlorine. And sodium has that 1s1. And chlorine is, 3s1, and chlorine is 2p5. And so this wants to get rid of an electron. This wants to gain an electron. So they end up going Na plus because it's lost that electron, Cl minus, and then you have a magnetic pole of attraction between them. In physics, we look at this attraction, and there is an equation that calculates the energy involved, and there's a constant 2.31 e to the negative 19 joules per times nanometers Q1 Q2 over R. The energy, the E is the energy of the bond that will form here. Q is the charge of the nucleus, or of the atom. So in the previous one, you would have a +1 and a -1 for Q1 and Q2. And R is the radiuses, or the radii, of the two ions. Because we're going to have our first nucleus and then its electrons, and our second nucleus and its electrons, and here's where they're going to be sharing those electrons, or the one's going to give the electron, and so we're interested in the distance from this nucleus to this nucleus, so the two radii of the two atoms. Looking at this equation then, E equals the constant K, Q1, Q2 over R. The things that really matter on the energy for an ionic bond is how big of a charge do we have and how close are they together. The closer they are, the larger the energy. Right, so that this is a small number. And if it gets to a bigger number, it's not. And then the more charge you have. So if you have a huge negative charge and a small positive charge, you're going to have more than if they're both small. When we start calculating this length, the energy, we say that if I've got just two atoms here and here and they're not interacting at all, that they are at zero energy. Okay? If it's a positive and a positive, we would expect the energy to go up, which we don't want to see. Okay? If it is a negative and a positive, what we're going to see with this chart is, if this is 0 along here, there will be a gradual decrease in how much energy as they approach each other until we get to a maximum down here, and then it will rapidly rise as the two nuclei get close enough that the protons actually start repelling each other. This here, this minimum amount of energy, is what we would call the bond length, how close they are going to get together to form that bond. The book has a really nice way of saying this. I really liked it when I was reading it, so I'm going to repeat it. When we say a bond is formed, we mean a molecule is more stable, less energy, than two or more separate atoms. By a certain quantity of energy. This energy is the bond energy. Okay, so the energy associated with making that bond. Covalent bonds then. So that was ionic. Covalent is when they share equally. So I have hydrogen and I have hydrogen, and the electrons are shared equally in the middle. They're attracted to the nucleus of this hydrogen and this hydrogen equally. Polar covalent. This is the arm wrestling and everything that we did last year, is when we have something like H and F, where F is definitely stronger, and so the electrons are going to be more towards that, resulting in a partial positive and a partial negative, which we call the polarity, hence polar bond. Alright.